Hello, welcome to today's lesson. We are building upon the inverses and solving 2x2 matrix equations that we did in the last lesson, and we're kicking it up a notch and we're going to solve 3x3 matrices. So we're still going to use those same skills that we've used in the previous lessons. So an inverse, again, just a recap. The notation is a to the power of -1. And if I multiply an original matrix by its inverse, when I multiply those two things, I should get the identity matrix. So remember, a 2x2 was 1, 0, 0, 1, and a 3x3 was 1, 0, 0, 0, 1, 0, and 0, 0, 1. Each of those had the ones going down the diagonals. We are personally just going to stick to use of the graphing calculator so that we can get the inverse of a 3x3 faster. And we know how to do the determinant, we've done that, but then to do all the other stuff inside the elements of the matrix, it takes a little bit longer. So we're just going to use graphing calculator to help us out. And as always, please remember, if you see singular matrix as an answer, it does not necessarily mean you've done something wrong. I would double check your work, make sure all your elements are entered correctly into the graphing calculator and that you've multiplied in the correct order. But you can have singular matrices, those that do not have an inverse. So if there's not an inverse, that means the determinant was 0, and you won't have a solution to this particular system. All right, let's get started. For these examples, we are going to be dealing with 3 linear equations, and they are going to have 3 variables. So now we are looking at 3D shapes. So think about a wall. If you look at the wall in front of you, the wall to the side, and the ceiling, the corner where all 3 of those would intersect would be the solution. And these are going to be called an ordered triple. And you'll put them in order of X, Y, and Z. Okay. So quick little math humor. I think this is kind of cute. Only in math problems can you buy 60 cantaloupes and no one asks, what the hell is wrong with you? Nobody asks that. Now people do that. I mean, think about restaurants. Obviously they buy 60 cantaloupes, but you know. All right, so let's get to it. Make sure you have your graphing calculator ready to roll through the steps of our 3x3 matrix equations. So first, entering our data into our calculator, we need to enter in our coefficient matrix. So ours are going to be 3x3s into your elements. Then enter your constant matrix. These will be a 3x1 for our examples. We'll go back into our matrices and we will select the first matrix, then press the inverse button. And then we will go back into the matrix options and select the second matrix wherever you put it, and that should put A inverse multiplied by B, or whichever ones you have. Press enter and it will give you the solution written in matrix form. You can then change it into an ordered triple for the examples we're going to deal with today. So I've already got ourselves a little bit of notes, reminders from the last time. We need to have a coefficient matrix multiplied by the variable matrix to equal the constant matrix. And our first few examples, we are just straight up practicing our skills. So we're going to take the coefficients of the first equation, 1, 1, and -3, followed by the second row is the second equation, 1, -1, and 2, and our third equation is 2, 1, and -1. Those are our coefficients. We're going to multiply by, we have 3 variables, x, y, and z in this case, and our constant matrix are those values that our equations equal, -10, 3, and -6. Okay, and remember our setup is going to be the variable matrix equals the inverse of the coefficient matrix, excuse me, so that should be 1, 1, -3, and 1, -1, 2, and 2, 1, -1 raised to the power of -1, that's the inverse of the coefficient, multiplied by the constants, -10, 3, and -6. Again, double, triple check. Make sure you've got all of your elements in each of those into your graphing calculator written exactly as needed. And when you multiply through, you should determine that the inverse is going, or excuse me, the solution is going to be -2, 1, and 3. So for the 3 points where my line would intersect, they would be an ordered triple of -2, 1, and 3. There you go. Okay, second example, same setup. We need our coefficient matrix of x plus 2y plus 5z, so that's a 1, a 2, and a 5 for the first row. 2x minus 3y plus 2z, so 2, -3, and 2 for the second row. And for our third row, we have 3x plus y minus z, so 3, 1, and -1. Our variable matrix is all of our x, y's, and z's. And our coefficient matrix is the solutions we have those equations equal to. -17, excuse me, that does not look like a 17. -17, -16, and 3. And to determine the values of x, y, and z, that ordered triple, we are going to take the inverse of the coefficient matrix. And again, we are not doing the work by hand for this one. We're using our graphing calculator to help us out. Raise it to the power of -1 and multiplying that by the constant matrix, -17, -16, and 3. Your solution at the end, hopefully you get all this typed in correctly and don't make any silly mistakes. You should have -1, 2, and -4. So your ordered triple will be -1, 2, -4, written in parentheses, horizontal. And again, think about the wall. So think about a 3D, kind of visualize 3D, and it's where all 3 of those walls would intersect in one corner. This is our last example that is given to us just as it is. The next and final example for today's lesson is going to be a word problem that we will have to go through. All right, so our coefficient matrix, take the coefficients of each of the elements from each equation. So 2x -4y plus z will be 2, -4, 1. 8x minus 2y plus 4z would be 8, -2, and 4, and -4x plus y minus 2z would be -4, 1, -2. That is our coefficient matrix multiplied by our variables x, y, and z, and our constant matrix is represented by 3, 7, and -14. So when we determine our solution, we need the inverse of the coefficient matrix multiplied by the constant. So we're going to have the inverse of 2, -4, 1, 8, -2, 4, -4, 1, -2, raised to the power of -1, that means inverse. Multiply that by 3, 7, -14, that 3 by 1 matrix. And when I press this one into the calculator, it actually shows me the words singular matrix. Okay, so what in the world does that mean? We've talked about it a couple of times, guys. Don't forget, if it is a singular matrix. Now you can take a moment and double check, make sure all your elements are correct, make sure you multiplied correctly, make sure you hit the inverse button and you didn't get some other crazy information. But a singular matrix means that the determinant equals 0, which means that there is no inverse. So if there is no inverse, then that means for this particular example, there is no solution. So these 3 lines will not intersect in a particular point. It's okay. Your final answer should be no solution. Not a problem at all with that. It happens from time to time. All right, our last example for the day. We have a word problem talking about a triangle. The second angle of a triangle is 50 degrees less than 4 times the first angle. Stop for just a second. Don't freak out. Keep reading. We'll come back. The third angle is 40 degrees less than the first angle. Determine the measures of all 3 angles of the triangle. Okay, so let's think about a triangle and we'll take it step by step. I need, let's say, an X, a Y, and a Z. You can call them A, B, C, D, E, F, P, R, Q, whatever you want, doesn't matter. Okay, so I need to label X to be my first angle, Y to represent my second angle, and the Z to represent my third angle. Okay, so that's just getting me kind of set up. Now I can go back and work sentence by sentence in order to get the linear equation so I can create my matrix equations and solve. So the first sentence, the second angle, okay, so that's Y, of a triangle is, that always means equal, so Y is 50 degrees less than 4 times the first angle. Okay, so you really need to do 4 times the first angle, 4 times the first angle is X, and then subtract 50 degrees less, so then subtract 50. Okay, so there's our first equation. Check, that one is done. Our next equation is the third angle is, so our third angle is Z, is means equals 40 degrees less than the first angle. Okay, so I'm going to start with the first angle and I'm going to subtract 40 degrees. And there we go. That's 2 of our equations. I've got 3 different variables. I have 3 vertices of a triangle, so I'm going to have 3 variables, 3 equations. And then it says determine the measures of all angles of the triangle. Okay, well, you got to dig back to some geometry stuff. What do you know about the angles of a triangle? All 3 of them, when I add them together, have a sum of 180. All right, there are our 3 equations. Now we're going to rearrange the first 2 that we wrote so that we can have each of them in standard form with the X plus the Y plus the Z equaling our constant value. So I'm going to rewrite Y equals 4x minus 50 in standard form by subtracting the 4x to the other side. So that will give me a negative 4x plus y equals negative 50. Okay, so I'm going to chop that guy off and rewrite it the other way underneath. Negative 4x plus y. I don't have any z's, so you can put a 0 there as a placeholder if you need to, plus 0z equals negative 50. All right, we'll do the same thing for the next one. We're going to take z equaling x minus 40 and put it in standard form by subtracting x on both sides. So that will leave me with a negative x plus z equals negative 40. So I have a negative x, no y's, plus 1z equals negative 40. Okay, and again, if you need to put those placeholders in, you can. 0z and 0y. Okay, now we've got everything exactly how we need it. I rearranged each of those equations and I can go ahead and write my matrix equations and solve. So the coefficients are 1, 1, 1 for the first equation, negative 4, 1, and 0 for the second, negative 4x plus 1y and 0 z's. Gotta have that value in there. You can have zeros, it's okay. And then our third one is negative 1, 0, positive 1, negative 1x, no y's, and a plus z. That's our coefficient matrix. It gets multiplied by x, y, z, and it equals the constants 180, negative 50, and negative 40. Okay, so if you enter the rows in differently, that's okay as long as they all match. So I've got to have the coefficients and the value for the constant all across the top, or all across the same line, whichever row they're in. The coefficients and the value for the next equation and the third equation. So it doesn't matter the order, but you just need to make sure that they all match. All right, so at the very end, when we go through and we do the inverse and we solve, you should have solutions of 45, 130, and 5. Okay, so those are perfect. Great job. You answered the question. But can you explain what that means in terms of this example? Okay, so go back. This is the I thoroughly understand it all the way out. So the first angle is 45 degrees. The second angle is 130 degrees, and the third angle was only 5 degrees. So that last angle was really, really, really tiny. Again, that first angle is 45. Trying to erase that to make that prettier for you. The second angle has a degree measure of 130, and that third angle has a degree measure of 5 degrees. Great job, guys. You guys have done really well with inverses and solving both 2x2 and 3x3 matrix equations. You have some practice on worksheet G. You can check your answers in the answer keys that are posted online. And again, you have a quick little quiz at the end of this week. It will involve inverses and solving matrix equations, both 2x2s, 3x3s, and a couple with some word problems. So be prepared for all of that.